8.8, proof testing for chemical fasteners and friction fasteners. General, do you want to elaborate a little bit on this?
Yeah, so this is probably one of the largest changes of standard, at least referring to our product. Probably the biggest one. So I guess we should start this section by jumping back to what we missed in section 3, and that is that the requirement for friction and chemical anchors to be in twice the shear load as they are in the tension load, also known as the 20-degree rule, has been removed.
Yep.
There's a very, very simple reason for this, in that these fasteners, all the information that the manufacturers like Hilti, like Fisher, like Worth, Icons provide, say their fasteners are stronger when installed correctly in tension than they are in shear.
Yep.
So, quite simply, that requirement has gone. Now that leads us to what do we do for proof testing?
Yes.
That becomes more of an important step, I guess, because if you're taking away some of that safety factor in limiting the range at which an anchor can be loaded, we need to understand, or make sure at least, that that anchor has been installed correctly.
Go.
So general. Proof testing. There's two different categories for what you have to do. The first one is for a single fastener component. So we have an example here. And this is any component. Now, there's always been confusion around these chemical and friction fasteners, of whether they only apply to anchors or whether they are anything that's permanently fixed to a structure, like a horizontal lifeline or a horizontal rail system. It is very clear now in the standard that it is all chemical and friction fasteners used for anything. Whether it's an anchor, horizontal lifeline, rail system, they are subject to this clause. So the first bit is the single fastener that I was saying here. So there's a lifeline bracket. It has one fastener holding it in the concrete. That is subject to an annual proof test.
Okay.
Every year, that proof testing has to be conducted. There is no way around that. Now, the second part, 8.8.3,
yep,
is for multiple fastener components. So an example here,
yep,
of a post which has, as you can see, up to 6 brackets, but we recommend fixing them at 4 into concrete. Now, this can be exempt from an annual proof test. There are a few things that it has to meet.
Okay.
Firstly, all the fasteners must be within the limitation given by the fastener manufacturer. So, for example, let's say that's Hilti. Hilti provide limitations on their fasteners for the loads that they can take.
Yep.
They provide an online calculator for you to easily calculate these loads and see what's going on there. You must be within what they say is acceptable. You can't exceed that. The next part is the fastener manufacturer's installation requirements must have been met. So if they're requiring for the strength of fastener that the hole is pneumatically cleaned, which is a rare thing, but just as an example,
yes,
then that must have been done. If they require that their fastener is set with a specific tool, it must be done with that specific tool. So we must meet the requirements that the fastener manufacturer has there. The third one is the fastener manufacturer's warranty must still be valid. So if they warrant the product for 10 years, this proof testing exemption would only last for that 10 years. Beyond that, you would need to continue the proof testing.
So the exemption only happens for the life of the warranty by the fastener manufacturer.
By the fastener manufacturer.
Okay. Yep.
Now, in saying that, some of the manufacturers allow it to allow it to 100 years. So we won't be around to worry about that.
Or the building.
Yes, or the building. The final part is the installation documentation must be included, and there must be evidence of the following things. So this is the important part, and this is for the manufacturer. They need to make sure, not the manufacturer, the installer of the product. The installer must make sure that they have a record of the initial proof test, so that the fastener has been put in correctly and has been validly proof tested.
Valid.
All the documentation of the previous things, like the calculations and the fastener, and how the fastener was installed, must be kept and recorded. And if all that information is available, then for that year, the proof test can be
exempt the lot, the warranty of the chemical that's used. So you've got to have part of the handover document. You've got to have the manufacturer of the anchor, and obviously the relevant information, and as well as the manufacturer of the chemical. So we'll use Hilti as an example, or Fisher, and all the documentation to show that it meets the requirement for that anchor as well. That then makes them exempt on this multi-fix.
Yes, again, only for multi-fix.
Okay.
So components that are fixed with multiples.
They still need a visual inspection?
Still need to do a annual visual inspection to make sure that the product is installed and that the anchors are not corroding or rusting. It's just the exemption approved test.
So that said, back to anchors that do need to be pull tested. One of the biggest things I'm seeing in this standard now is there is a time frame for the pull test to be held. So previously we heard rumors that people were doing it for 1 minute, they were doing it for 3 minutes, they were doing it for 15 seconds. But I see in this standard that the load shall be held for no less than 30 seconds.
Yep. So there's been a method that has been specifically created for this. It's also given more guidance on what load should be achieved for your proof test. So it's always been 50% of the rated load. That is now 50% of the design load of the fastener. So there will be some product that this is not 7.5 kilonewtons, where to achieve a load on a specific anchor, the fastener may actually need to take a lot more than that. A great example is davits. For all floor-mounted davit bases, the rear 2 bolts are going to take a lot more than 7.5 kilonewtons.
So we're talking about the design load of the fixing. We're not talking about we use a davit as an example, not the 15 kilonewtons, because there was a myth out there we'll call it a myth, for quite some time, that you got 15 kilonewtons and you only gave 15%, or you divided it by 4 because there was 4 fixings, and then you 50% loaded that. So there was that method out there. There was a few others, but what we're saying is so if the design load is 30 kilonewtons per bolt, it's 15.
Yes, it's 50% of the design load. The other thing here is it may work the other way. You might have many fasteners and the design load is actually way less than 7.5. There is a minimum put in here that it shall not be less than 7.5 as a minimum. And as you said before, held for 30 seconds.
Yep, that's probably one of the big ones, and that's one of the ones we get asked a lot. So really, the stuff worth noting in 8091.4, we've just covered off from our perspective what we see as a change, and we see the change for the greater good. The inclusion of other standards, which has been a big one. So the inclusion of 5532, 8091.5, we also 0.1 as well is in there as well. So that's pretty big. So yeah, thanks very much, Oscar.